Okay, so today, as I mentioned, it's just an extension of yesterday's. So there's not really much notes I need to give. Your rules are actually the same. When you have two of these fractions that you're going to multiply together, you still only have, I don't know, how many rules are you going to have? Let's see. So how to this time? You're still going to start by factoring every numerator and every denominator separately. So very similar to yesterday, you're just going to factor everything. This time, we just might have more than one numerator, more than one denominator, because we're multiplying them together. So we're going to factor everybody together first. And then in your second step, we're going to reduce or cancel any numerator. Well, let's say anything in the numerator. Anything in any numerator with anything in any denominator. You'll see what I mean when we do one or two of these out. What I'm trying to get at is you don't have to reduce two things that are in the same fraction. I could reduce something in a numerator over here with a denominator over here. It doesn't matter. Anything in any numerator can reduce with anything in any denominator. That's it. So it's just like two problems together. So let's start off with a nice, easy one. I don't know, number. I don't know. Someone pick a number between 1 and 12. 6. Okay, 6 is good. So step 1 is to factor everything. These don't have any factoring to do. So there, step 1 is done for me in this case. Now in step 2, I can reduce or cancel anything. So anything I see up here that will cancel with anything down here, I can do that. So for example, it's jumping out at me 3 and 9. So I can cancel those. 3 goes into 3 once, 3 goes into 9 3 times. But now look, I have 3 and 6 in the same fraction. You can still reduce them. It doesn't matter. Anybody in the numerator can cancel with anybody in the denominator, same fraction or not, does not matter. So let's reduce 3 over 6. 3 goes into 3 once, 3 goes into 6 twice. Right, this is all multiplication. Okay, so I took care of the numbers. Let's see. Now let's take care of the ends. Don't I have n squared essentially on top, right? Because I have 2 of them, and then I'm going to have an n squared on the bottom. So aren't all the n's just going to cancel? Do you see that? See, I have n squared on top with n squared on the bottom, really? So all the n's are just going to cancel each other. So what's left? In the numerator, all I have is 11. In the denominator, all I have is 1 times 2, so 2. That's it. Let's try one that has some factoring to do. How about something like 9? 9 looks good. So 9, step 1, let me zoom in a bit here. Step 1, I just have to look at each piece and factor it. Nothing to do there, nothing to do there, nothing to do there. Oh, this one, I can factor that. What does that factor into? Yes, I have p plus 2 and another p plus 2. That's now done. So now step 1 is finished. Everybody is factored as far as they can be factored. Now I get to come in and cancel or reduce anything that I see. So let's see, what do I see? Oh, I see a p plus 2 up here that'll cancel with a p plus 2 down here, right? Because it's the entire binomial. So I can cancel all of that with all of that. Do you see anything else I can do? Bless you. No, that's it. That's it. You can't touch. I know you might be like, oh, can I do those p's? Because that p has a plus or minus right after it. So that one is part of a binomial. So you can't touch that unless you have an identical p minus 7 on the denominator, which I don't. So I'm done. I can't do anything else. So then I just write everything that's left. So up top, I have p minus 7. And on the bottom, I have 8p times p plus 2. That's it. The only way this gets harder is by trickier factoring, right? So let's jump to, why don't I have you guys try number, I feel like these are all like either super easy or super complicated. Try 14. That's like a medium one, I guess. Yeah.
Pencil.
I do.
Yeah, I have a pencil, please.
Actually, can it be a pen?
That's
How about that green one?
fine.
Okay,
Just for-
how'd you do? So, everybody has an answer?
Yeah.
Yeah. So again, you gotta ignore, your very first step has to be to factor everybody. So you are really just gonna look at each one by itself. So right here, couldn't I take out 35n squared? That would leave me with n plus 2. Right? Do you agree with me?
Okay.
There's my very first one, 35n squared. Yep, okay. That one's done. I move on to the next one. What can I take out of this one? 4. And then I'm left with 2n minus 5. Okay, this one, what can you do? Take out a 45. That leaves me with n plus 2. This one, what can I do? Nothing, so that one just stays. All right, cool. Now step 1 is done. This is another one of those, I'm telling you, kids are gonna get things wrong because they cancel before they factor. For the love of math, you have to factor first. Now I'm done with the factoring. Now I come in and I can cancel whatever I want. Right away, I see an n plus 2 over an n plus 2, that's gone. I can do the 2n minus 5 with the 2n minus 5, that's gone. And now I can reduce the numbers too, right? 35 over 45, I can reduce that just like a normal fraction. 5 goes into both. 5 into 35 is 7. 5 into 45 is 9. Anything else? Another common mistake is just writing your answer too quickly and not realizing, like, I never canceled out that n squared. That's still there. So I have 7n squared and a 4. So you're multiplying all this together. So what's my numerator really? You multiply all that together, what do you actually get? I feel like I heard someone say it. Wouldn't I get 7 times 4 is 28? So I'd have 28n squared. That's what's left in my numerator. Oh, sorry. Just multiplying everything that's left. Just make sure you're taking the time to actually make sure you see everything that's left. All right, then on the denominator, literally all I have left is 9. So I have a 9. It's worth just a quick glance to make sure that you didn't miss something. Is there anything that I can reduce here? No, so I'm pretty sure that I'm done. Let's do one tough one together, and then I'll show you how to divide, which is just as easy.
Not so smart.
It's really not bad at all. 18, let's try this one. So the only reason this one is tougher is just because I have harder factoring to do, that's it. But we know how to do it. I like to, whenever I have these ones, I like to do the works like, it gets too messy if I try and do it right here. I don't know. So I'm gonna use another piece of paper. So if I'm factoring that thing, so I do 8 times, or I do slide and divide. So that's my method, but you do your method. So let's see, I need factors of 450 that add up to be 43. So 45 and 10 don't work. How about 50 and 9? Oh, I'm close. Oh, I'm so close. Everybody find them yet? Got it, 18 and 25. Yeah, okay, so I did the slide, I multiplied by 10, now I gotta sneak in and do the divide by 10. Right, I gotta reduce this fraction, so that becomes 9/5, so that turns into 5r minus 9. Over here, reduce this fraction, that's 5/2, so that's 2r minus 5. So whichever method you're using for factoring, we should have come up with these same two. I'm gonna FOIL it back together real quick just to make sure that I'm right. That'd be a minus 25 and a minus 18, and 25 and 18 is in fact 43, which is what I wanted. Yep, and then plus 45. Okay, so I got my 2. So this thing is going to factor into 5r minus 9 and 2r minus 5. All right, there's that one. This one, what does that factor into? Come on, I'm giving you the easy one. Thank you. A minus 7 and a plus 3. All right, then down here, I have another one where a is not 0, but this one shouldn't be too bad. So I'm going to do slide and divide. You do what you do. So I multiplied by 2, so now I got to divide by 2. So on one hand, I get 2r minus 5, and the other one is just r minus 1. All right, that wasn't so bad. And then 5r minus 9, there's nothing to do there, so it just stays. Now that you are done with step 1, factoring everybody, literally, as much as you can, now I can come in. Sometimes it's fun to use a different color for your reducing. So if you want to do that, you could. I'll try this orange. I see a 5r minus 9 and a 5r minus 9. 2r minus 5s. And I think that's it. So what do I have left? Up top, I have r minus 7r plus 3. And on the bottom, I have r minus 1. And I'm done. That's it. You can't do anything else. Don't bother foiling it together. Right now, there's going to come a time where we have to, but right now you don't have to. So leave it. So could we multiply? All right, let me show you how to divide. If you flip this paper over, you'll see division problems. Oh my gosh. Only 2 steps for these also. How do you divide? Let's just look at the first one, number 19. How do you divide fractions? Keep, change, flip. You literally just turn it into a multiplication problem. And then you do exactly what we were doing. So how to divide? Step 1, rewrite as multiplication. Rewrite as multiplication problem. So we say keep, change, flip. And then you, oh, sorry. Now you do it as a multiplication problem. So I'll just say solve as usual. So if I were going to do number 22, for example, step 1, rewrite as a multiplication problem. Keep the first fraction exactly as it is, 16p over 13p. Change the division to multiplication, and now you have to flip this second fraction over. So now it's 2 over 10. And now you do exactly what you did on the other side. Factor everybody and cancel. In this particular one, nobody factors, so that's cool. So now I'm allowed to just cancel. P's will cancel with each other. Switch to my orange. P's cancel. What else could I do? 2 over 10, that becomes a 1 over 5. Anything else? I don't think so. So just multiply everything together. So up top, I have 16 times 1 or 16. And downstairs, I'm going to have 13 times 5, which is 65. That's my answer. That's it.
I like that.
Let's do a trickier one like 29 maybe. Don't go canceling anything. Step 1 is rewrite it as multiplication. So I know it gets tedious because it's annoying to rewrite them. So sometimes kids just try, well, we could, right? If I want to change that to multiplication, and now this thing's just going to flip over. So it's going to be a plus 4 on top and 2 on the bottom. Let me just, there we go. So step 1 is done. I did that part. Now I'm going to solve this like I normally do. So normally I have to factor everybody. So from this side, I could take out an 8. And I'm left with a plus 7. A plus 4, there's nothing to do. Down here, factors of 28 that add to be 11. 7 and 4. That one's done. And 2, there's nothing to do there. All right, cool. So now I get to come in and do my, oops, sorry, moved that too far. There we go. I'm going to cancel anybody that I can. So let's see. I see a plus 7s are going to go. A plus 4s are going to go. Can I do anything else? Yeah, the 8 and the 2. Let's reduce that like a normal fraction. 8 over 2, aren't I just going to get 4? And that's my final answer, right? Because the denominator is just a 1. So I just get that whole thing simplified down to just be a 4. Isn't that neat? So that is how you handle division. It's the same as a multiplication problem once you rewrite it. Questions? No? You sure? All right, so let me see what I want you to do. I'm thinking the next 2 pages, because it's only 18 problems, that's not so bad. And one's multiplying and one's dividing. So let's do that. So we're going to do pages 112 and 113. Oh, why are ancient stories like feet? I think I remember that one. That's funny. What's this one? Oh, you probably know what happened to the peanut who went walking late at night. Keep it, don't share the answer. Let's let people be surprised. But anyway, so try those 2. I'm just glancing. Remember when you get to number 3, remember what we talked about, ignoring the B for a second? And then you can.
Why are ancient stories like you got back?
You're welcome.
Wait, what?
You want to?
So, which ones are we doing again?
Let me look. There you are.
Thank you. Just which ones do you want us to do?
112 and 113. See the
Okay.
page numbers on the
Oh,
bottom?
yeah.
Yeah.
112 and 113.
Those are the 2. All right, let me go open this up for you.
I was just like looking.
It's not. They're not so
Looks a
bad.
little. Yes.
Remember, the answer to the riddle does not get you credit. I would expect to see, just like we did here, I would expect to be seeing them factored and you crossing things out, right? You're not gonna look at number 1 and just say, oh, I know the answer is like A plus B. There's work that you do to get there. So that's what I would expect to see. Just like we've been doing on all these problems in class. I know these answers are Googleable. I know you could photomath the whole thing, but how is that gonna help you, really?
Can I photomath it after I figure it out?
That's a great idea. I actually encourage you to do that, but you don't even need to because these sort of self-check themselves. You know what I
I'm
mean?
a little lost first.
112 and 113. So I'll do the first one if you need me to.
Yeah.
Oh, boy. All right. Well, so here's the very first one. This is a multiplication problem, so I'm ready to just factor. How does that top one factor? A squared minus B squared. What does that turn into? Yeah.
I did like AB parentheses A minus B.
A plus B, A minus B.
Yeah.
Yes. That's just the difference of 2 perfect squares. So that's A plus B, that's A minus B.
Wait, I thought we were doing a peanut.
Both 112 and 113.
It's the 113 extra credit?
No.
Wait,
One's multiply, one's divide.
Oh, we have to do both?
Yes, they're so fast.
But you should make one extra credit so that.
I don't think so. All right, that one, there's nothing to factor. That one, there's nothing to factor. But here, what can I do?
Take the 3 out.
Take out a 3, and then I'm left with A plus B. Okay, so now factoring is done. Now let's go ahead and just cancel whatever we can. There we go. I see A plus B. Let's cancel A plus B with A plus B. What else can I do? Look at the loose A's. You have A to the first and A to the fourth. What would be left when you cancel those? A to the third on the bottom. Here's another thing I'm going to recommend that you don't do. A lot of times kids just try and write over the 4 and make it a 3. You're never going to know what that says. Cross it out and rewrite it. I'm telling you. And then B's. B squared over B to the first would leave me with B to the first on top. So even this, I'm crossing the whole thing off and just writing it as B. It's so much clearer for you to see later. You're going to get so confused if you're trying to write over exponents or. Is there anything else I can do? I don't think so. So up top, all that's left is b times a minus b. Usually you put the loose things first, right? That's all. And then any things, what are these called? Binomials at the end. On the bottom, I have 3a to the third. And that's it, right? Okay, now let's look. Is that a choice?
Yeah.
Yeah, there it is, EB. So this, that's why I like this. I don't have to go to photo math. I just do my work and then I look, hey, is my answer there? Oh, it is. So I know I did this one right. You know what I mean, Jelly Bean?
Evan.
Yeah.
What?
Evan.
I have a question.
Sure.
Or you don't have to do two out, but see how there's like 5A and 5A. So like the top right one, you could simplify that to like A. You could take out A on that.
Yes.
Would you do that or would you cross out the 5A's first? Like would you simplify?
Oh, well, remember what the rules are. Step 1 is factor. Step 2 is cancel.
Okay.
Don't you dare cross anything out until you have factored everybody.
Okay.
All right. I'm gonna turn the light on. Let's see what you're doing. Question?
Here it is.
You can. So, well, no, but you can, remember we were talking about this at the beginning of class, you can cancel these two as long as you leave behind the -1. Yeah.
So.
Well,
So I have to.
Oh,
you could leave it on top.
7.
You would leave it, it
-1
doesn't
over-
actually matter.
Better. 7.
That's it.
Oh my god, I'm smart. I don't get it so far.
Yeah,
7.
like
7. 2. 7.